Hi, welcome to your first flip video of 3-1. 3-1 is all about the percent equation, and there's a good chance you already know what this is and how to use it. You've probably used it before if you've ever figured out your score on a test or a quiz or anything like that, so let's talk about it. So our percent equation, so before we talk about the percent equation, let's just throw out a couple of scenarios. So let's say you had a 10-question quiz, you scored an 80%, how many did you get correct? I know a lot of you right now can just be like, 8. I got 8 out of 10, that's an 80%, and that's great. Let's talk about why that works though, all right? So we'll throw out one more scenario. If you have a 25-question quiz and you got a 60%, how many did you get correct? That one's a little bit more difficult. The numbers don't line up quite as well. So the percent equation will tell us how to solve both of these mathematically, so we can do it regardless of what percent or number of questions correct or number of questions incorrect or the total number of questions on the test or quiz. So this is something we use all the time, and you probably don't even know that you're using it. So the percent equation, this is what digit says. Part equals percent times your whole. So in the examples above, the first one, the part would be the number of questions you scored correct, the percent would be your percentage, and the whole would be the total number of questions in the quiz. For the other one, it would be 25 total, that's your whole, 25 quiz questions, so that's your whole, 60%, and the part would be the number that you got correct, all right? We can also use this equation to find the number you got incorrect, because notice that it doesn't say part one way or the other. It doesn't say part is the part section is the number of correct or the part is the number of incorrect. So we can use it to find both percentages, which should add up to 100% because all the percentages together need to add up to 100%. If you're looking at number of correct or incorrect, because you either got a question right or wrong, there's no other in between. If you've ever used this equation or a math teacher ever told you how to figure out your percent if you had to use this in the past, they probably said part divided by your whole, all right? So this is the one that's probably a little bit more common. It's the same thing rewritten, right? Because if you have the percent over here, how do you get percent if percent was a variable? Well, you divide both sides by the whole, and percent would be left over on it itself, and then part divided by whole, because if you divide one side by a variable, the other side needs to be divided. So these are the same equation, just rewritten in different forms. All right, so let's apply this equation to these two scenarios. So I'll do the first one. Part, so I want to know how many I got correct. That's the part of the whole. I know how many questions are on the quiz. I know my percentage. I want to know my part. So P equals, and now I got to think about percentage, because if I plug in 80%, I'm going to get the wrong amount. So we have to change percent into a decimal so we can use that decimal in our calculators. So I know 80% is 0.8 because it's 0.8 out of 1. But let's say you didn't know that 80% is 80 over 100, and if you did 80 divided by 100 in your calculator, you'd get 0.8. So whenever you see 80%, it's 0.8 out of 1, because, right, if we took, let me switch colors really quick. If we had 80 over 100, I scoot my decimal point 1, 2, and then scoot this over 1, 2. This would be the same thing as 0.8 over 1. So when you go in your calculator and you get 0.8 over 1, what you're really getting is the reduced fraction over 1. All right? So I'm going to take that 0.8, I'm going to plug it into my equation for the percent part. All right, and then I know how many questions, I know my whole, I know how many questions were on the quiz, it was 10, so 0.8 times 10. So now P equals 8, because 0.8 times 10, you know, go into your calculator, plug that in. You could also use the idea every time you multiply by 10, you move your decimal point 1 to the right. So 0.8, the decimal moves from the left to the right. So 0.8 turns into 8 when you multiply it by 10. So P equals 8. So that means I got 8 correct out of the 10-question quiz. All right. For this other one, I'll set it up for you, and then I'd like you to solve it. So P, I want to know how many I got correct, equals 0.6, so 60%. A good rule is whenever you see a percent, so I'll do this down here, let's switch colors. Whenever you see a percent, so let's say 90%, whenever you see a percent, the decimal point's right there, scoot it 2 to the left, and that will tell you the decimal decimal amount. So 90% is 0.9. 9%, that decimal is right there, you're going to scoot it to the left, 1, 2, So decimal's right there now. So 0.9%, there's this gap right here. A 0 is going to fill that gap, is really 0.09. All right, so I guarantee people will make this mistake here and there throughout this unit, but just move your decimal point 2 to the left, and that will help you figure out the decimal version of a percent. So I have p equals 0.6, and I know how many total questions there are. There's 25, so p equals 0.6 times 25. Go into your calculator, p is 15. So what does that number represent? Is that the number correct or incorrect? Well, if I scored 60%, that means I got 60% of them right, so 15 questions wrong. So we can take this one step further. We can figure out how many questions you got wrong then. So if you got 15 questions correct, and it's a 25 question quiz, got to have 10 incorrect because I got to get up to a whole. All right. So if 60% is 15, then 10 have to make up the remaining percents that aren't in this 60%. So 10 questions have to be 40% of the quiz. All right. So you can use this to help you figure out missing parts. We're not diving that deep into 3.1, but just know that it's there and that you have that tool available to you. You can take this 40% and this, you can take this 10 and the number of questions correct, the 25, and you can solve for the number of the percentage of incorrect questions using the same equation that we've been using. All right. So to find, we have three things here, right? Because in our equation, we have part, percent, and whole. So if we want to find our part, our whole, or our percent, we have different ways to do that. And they all follow the same basic pattern. So to find your part, I'm going to put our equation up in the corner just so remember. Part equals percent times whole. And you'll see this probably referenced in digits at some point. Instead of using p, percent, and w, it's a little cumbersome and no one really uses those variables. You'll see a lot more commonly y equals mx, and this is the equation we used in topic 2. So y would be my p, m would be my percent, and x would be my whole. All right, so just keep that in the back of your mind in case you don't see p's and w's, you see y's, m's, and x's. This is what it's alluding to. It's the same thing. All right, so part, let's throw out an example question. What is 5% of 20? So I'm going to translate this into math symbols. All right, so what is an unknown? I'm trying to figure that out. That's my part. All right, so I'm going to use x is equal to, is means equals, 5%. So remember, if we go back to the last page, 90% is 0.9. 9% is 0.09, so 5% would be 0.05, so 0.05 of means multiplication, and 20 is just 20. So x equals 0.5 times 20, so we can go ahead and solve that. We're not going to spend the time to do that right now. I'd like to get to some more problems. We're going to do the same thing now for whole. So 10 is 5% of what number? So I could do 10 is, it means equals, 5% is 0.05, of means multiplication, and what number, I'm going to use a variable, so let's use x, or let's use w here. We can replace x if we wanted to for w, it's the same thing. So 10 equals 0.5 times w, and then I could solve for w, and that would be my whole. All right. Last one, 5 is what percent of 100? So 5 is means equals what percent? I don't know my percent, so I'm going to use a percent sign. You could also use an m or a k here. Doesn't really matter. Of means multiplication, 100, 100. All right, so now we could solve for that missing percent. So let's go ahead and apply this in some practice problems. So what I've done is I've screenshotted some questions from a homework assignment. This isn't your homework assignment. Your homework might look very, very similar to it, but this is not a homework question directly from the one that I've assigned to you. So 3 is what percent of 6? So let's go ahead and break that down. 3 equals percentage times 6, all right? Because 3 is, so reference that slide before if you're confused into how I got 3 equals percent times 6. I'm going to replace my percent with an m. I think that's something we need to get in the habit of, not using percent symbol p and w. Let's use the actual variables. So 3 equals m times 6. Well, how do you get m by itself? You're going to divide both sides by 6. The 6's will cancel out. So we have left over m equals 3 over 6. All right. So if you ever enter that into digits, it'll mark it wrong because it's not simplified. So 3 over 6 is the same thing as 1/2. So some of you might be able to say, I know what percentage 1/2 is, but let's talk about how you know the percentage. So 1/2 is really 0.5. If you go into your calculator, it goes 0.5. And we know from our first slide in this video that 0.5 really means 50 over 100. And 50 over 100 is 50%. All right? Because this, when you have your denominator as 100, then your numerator is always your percent. All right? So let's go ahead and try another one. So, local Little League has a total of 70 players, 20% of whom are right-handed. How many right-handed players are there? So we got to think about, what do we know here? Well, we know the percent and the total. We're trying to find the part, the number of right-handed players. So P equals 20% times 7. So I'm going to rewrite this as Y. So I'm replacing that P with a Y. 20% is 0.2, and then of 70 means times 70. So Y is equal to 14. All right, now let's talk about how you can check to make sure your answer is correct. All right, so if my part is equal to 14, we should be able to plug that into our original equation and we'd get the same answer. So 14, replace the Y value, and then I kept everything else the same because I don't want to change that. I want to see if I get the same answer. So 14 equals 0.2 times 70. 14 equals 14 because 0.2 times 70 is 14. 14 equals 14, which is true, means I got it right. All right, so you can use this method to double check your answers. All right, last one. Sorry about the formatting. It's a long question. Tom's math teacher asks, 8 is 25% of what number? Tom incorrectly says 200. What is the correct answer? So 8 is 25% of blank of what number? So the blank is the whole. So if I'm trying to figure out my whole, my total, 8 is my part, 25 is my percent, so 8 equals 25% times W. So then I'm going to translate that. So 8 equals 0.25 times X. Divide both sides by 0.25. The 0.25s cancel out. So on the right-hand side, all I'm left over is X. And 8 divided by 0.25 is 32. So X is equals 32. So we're going to go ahead and double check our answer. 8 equals 0.25 times 32, so all I did was I took that 32 from down here and I plugged it into our W. So 8 equals 0.25 times 32. If I go into my calculator, 0.25 times 32, 8 equals 8. Let's say you didn't have a calculator available. I know 0.25 is 1 over 4, which I could get from going 0.25 is 25 over 100, all right, which is the exact same thing as 2.5 over 10, which is the exact same thing as 0.25 over 1. So notice every time my denominator gets bigger by a 0, by a factor of 10, my decimal point moves 1 over each time, all right, because there's the decimal point right there. So we can go ahead and use that. So 0.25, if I wanted to do it like this, instead of doing 0.25, I could say 1/4. So 1/4 times 32, and I know 32 is the same thing as 32 over 1, so 32, we multiply, 1 times 32, 4 times 1, 1 times 32 is 32, 4 times 1 is 4, and now it's just a division problem. 32 divided by 4 is 8. Lo and behold, exact same numbers we've gotten all over the place. Okay, so this concludes 3-1. Hopefully we like the new format. If you have any questions, let me know.